In this video, I'd like to take a look at actually implementing EIGRP, and we're going to look at the Cisco iOS commands you would need to know from a CCNA level to implement and monitor and troubleshoot the enhanced interior gateway routing protocol. So many of these commands I've already demonstrated to you on the whiteboard in some of the previous videos where I did demonstrations, so a lot of this hopefully will be a review for you. So basic configuration commands. On any two routers that are directly connected, and that's number one. So EIGRP requires two routers to be directly connected on the same segment so they can become neighbors. In other words, if I have 1, 2, 3 routers, routers 1 and 3 will not form EIGRP relationships through router 2. Now, when you get to more CCIE level topics, you'll learn there actually is a way to do that, but the CCNA level, what I want you to focus in on is two routers have to share the same cable, the same IP subnet in order to become neighbors. If that is true, then secondarily, they have to have the same EIGRP autonomous system number. So as part of your router EIGRP command, you're going to put some AS number in there. It can be whatever number you want, as long as it's the same on all the routers. And then I'm going to skip no auto summary for just a second. And then we already talked about the network command a little bit. The idea here is that if I have a router that has, let's say, 3 interfaces, interface 1, 2, and 3, if I want this router to start speaking EIGRP on interface number 3, well, then I have to ask myself, what is the network on interface number 3? Is it the 99 network? Is it the 120.120 network? What is it? And whatever that network is, I'm going to implement that with the network statement. So that network statement does two very important things. Number one, it activates EIGRP. So for example, if I said network 20.0.0.0, this router would look around and would say, do I have any interfaces that are actually up that have an IP address, IP version 4, and start with the number 20? So let's say interface number 3 here had the IP address of 20.20.1.1/24. Well, EIGRP would say, yep, so this first number is a 20, so I'll activate EIGRP right here on this interface. I'll start sending out EIGRP hello packets. And if there's another router on this segment who can send me his own EIGRP hello packets, we might be neighbors. Similarly, if interface number 2 here had an IP address of 20.40.1.1, well, that starts with the number 20, so EIGRP would also be activated on this interface and start sending out EIGRP hello packets. So that's one thing the network command does. It activates EIGRP on any interfaces that are up that fall within that network. Second thing it does, it says, okay, I am now allowed to advertise that network to my neighbors. Now keep in mind, this will only advertise networks that you are directly connected to. In other words, let's say that there was another router right here. So this is router X, and here is router Y, and these two guys are directly connected. Well, if on router X, I added another network command, like let's say network 99.000. If router X does not actually have any interfaces connected to something beginning with 99, that network command would do nothing. I won't get any kind of error message. It just will have no effect whatsoever. So the network command, now if I actually had an interface here that began with 99 dot something, that network command would allow that network to be advertised from router X to router Y. But a router can't advertise a network he actually doesn't know about. He can only advertise networks that he actually is aware of, that he knows of. One other thing about the network statement. So you might look at this and you say, well, Keith, but in this case, by simply having network 20.0.0.0, you're saying EIGRP will be activated on interface number 3 and interface number 2 because they both have IP addresses that begin with 20. What if I didn't want EIGRP speaking on interface number 2? Didn't want to speak on that interface at all. I only want speaking on interface number 3. So let's erase this right here. So erase this little circle. So I only want it on interface number 3. Well, how do I do that? With the network command, there is an optional wildcard mask that you can assign to it. So for example, under my router EIGRP, and then whatever my autonomous system is, I could say, I'm going to do it over here so I've got a lot of room. I could say network .20.1.0. Now, if I just type that and then I hit the enter key or the return key on my keyboard, what you would see is it would take the iOS operating system would look at that and say, okay, what is this first number here? What class of address is that? Is that a class A, B, C, D, or E address? Well, hopefully you can instantly say, oh, 20, that falls in the class A range. So it would look at that and say, oh, well, the only number here I really have to pay attention to is 20. So now, even though I typed in network 20.20.1.0, if I look at the running config output, it will actually have condensed that down to just 20.0.0.0. So even though I typed in a specific subnet, it would override that and just give me back my classful address. This is where a wildcard mask comes into play. Because if I actually want to keep it like this, I can type in at the end of it a wildcard mask, just like you use in access lists. 0.0.0.255. And now with that wildcard mask in there, EIGRP knows, okay, I'm not allowed to condense this. I can only operate on networks that begin with 20.20.1. So it's your choice. If you don't use a wildcard mask, you might as well just type in a classful network. Because if you type in a subnet, it's just going to shrink that down to a classful network anyway. But if you specifically want a subnet in there, like in this case, I only want EIGRP operating across this network and that's it, that's a good use case for where you would type in the wildcard mask. Now, let's talk about the auto summary for a moment. What does this do? So auto summary, or I should say the command auto-summary, used to be the default. That when you typed router EIGRP and then you did a show run to look at your running config, you would see auto-summary right there, even though you didn't actually type in auto summary. And what's the behavior of auto summary? Well, the behavior was something like this. Let's say for a moment that I have EIGRP running between switch 2 and router 3. Okay, so these guys are EIGRP neighbors. And now switch 2 is going to advertise this network and this network to router 3. Well, if switch 2 is running auto summary, switch 2 would say, both of these are subnets that begin with the classful 2 network, and yet the network where I'm talking to router 3 is a different network. It's a totally different network. It's the 3 network. So with auto summary, he'd say, okay, instead of sending these specific subnets, I'm just going to send this 2.0.0.0/8. I'll tell him he can reach the entire class A address of 200/8 via me. That's what auto summary did. It basically said, okay, if the outbound interface where I'm speaking is in a different network than the network I want to advertise, I'm going to summarize the network I'm advertising. I'm going to summarize it down to its classful boundary. Most people don't like auto summary, and it used to be that as just part of your normal configuration when you were typing router EIGRP, you would just get used to typing no auto-summary. Because in reality, if you do want to do route summarization, you're going to want to control it. You're going to want to control what routes are summarized and what routes aren't summarized. You're going to want to control what the mask looks like of those summarized routes. When you use auto summary, it takes pretty much all of that control out of your hands, and people don't like that. So in most recent versions of Cisco iOS, actually now the default is no auto summary. So that's already the default, but you might not know. If you're running on a router or switch, you're not necessarily going to know, okay, is this software defaulting to auto summary or is it defaulting to no auto summary? So what I would recommend is it just as part of your knee-jerk reaction of configuring EIGRP, when you configure it, you should just type in no auto-summary. When you get to the CCNP level, you learn all the tricks of how to actually do route summarization in EIGRP. But the CCNA level, just take away from this. I want to type no auto-summary. I do not want EIGRP to automatically summarize anything. And we know that autonomous system numbers should match between EIGRP routers. So let's just do a real quick configuration here using that exact same whiteboard I talked about. So my objective here is I'm going to want EIGRP to be operational between switch 2 and switch 3, and between router 2 and switch 2, and between these three guys, between switch 1 and router 2. So my goal is I want switch 3 right here to be able to successfully learn about the 1.2.1 network. So he can ping it. So he can ping 121.11 or 121.2. So I need to form some EIGRP relationships here. So the first thing I have to think about is, what autonomous system number do I want to use? And since I can use anything I want, I'm going to use autonomous system number, let's see here. How about 1223? 1223. Since I've got switch 1, router 2, switch 2, switch 3, 1223. Okay, so let's go ahead and start, and I'll configure EIGRP between switch 1 and router 2. And if you haven't already done so, you might want to take a screenshot of this topology here so you can follow along with me as I'm configuring this. Okay, so let's first go to switch 1. So I have to go into global configuration mode, and it's from here where I type my router EIGRP, and then I give it my autonomous system number, 1223. Okay, now I'm on switch 1, so the first thing I want to do is I want to make sure that EIGRP is activated and running on this interface right here. So I ask myself, what network is that? Well, I've got two options. I can type in network 1000, and if I do that, it'll activate EIGRP not only on 0/2, but also on 0/1, because that's also in the 1 network. And actually, I think that's a pretty good idea. Why not just use one network statement to pick up both of these interfaces? So I'll do that. I'll just type in network 1000. And now let's make sure that this device does not do summarization. So for my basic EIGRP configuration, that's it in switch 1. It was really just 3 commands. Router EIGRP, network, and we can see in this platform, no auto summary must be the default because I typed it in and it's not showing up here. And usually in Cisco iOS, when you type in a command and it does not show up in the running config output, that means that what you typed in was already there. It was the default. All right, so now let's go to router 2, and I'll configure EIGRP, and I'll include network 1 and network 2 for router 2. Router EIGRP, and give it the same autonomous system number. No auto summary. Network 1, network 2. And you can see just how quickly, within like a second after typing network 1, I formed a new EIGRP neighbor relationship. So router 2 and switch 1 are now EIGRP neighbors, and I can confirm that by using the command show IP EIGRP neighbor. And you can see here on router 2, he says, I am now neighbors with 121.11. That's switch 1. This is the interface where I am speaking to that neighbor. And when I issued the command, he had been neighbors for 24 seconds. Now he's been neighbors for 40 seconds. And this is the last sequence number we saw. So the last reliable packet, which was most likely an EIGRP update that we received, had sequence number 3 on it. These other counters here, SRTT, RTO, and Q count, you don't really need to know what those are for the purposes of the CCNA exam. And what we should also see now is that router 2 should now be aware of the 1110 network. That should have been advertised via switch 1 to router 2. So we can go into his routing table, show IP route, and there it is. The D indicates it was learned by EIGRP. because D stands for Advanced Distance Vector. Some people have also said it stands for dual because EIGRP uses the diffusing update algorithm. So I'm not sure who you want to believe, but you can impress your friends by saying, hey, that stands for dual or Advanced Distance Vector. And here is your prefix. It was advertised as an EIGRP internal route, so that's an administrative distance of 90. Here is my feasible distance, 30,720. My EIGRP neighbor that told me about that route was 1.2.1.11. It's been 1 minute and 20 seconds since I learned of that route, and I can get to that route via Fast Ethernet 0/0. I can also see what that entry looks like in the EIGRP topology table. Show IP EIGRP topology. And there it is. So P means passive. That means that route is good. I can use it to forward packets. There's the prefix. I have one successor, and just like we saw in the routing table, the feasible distance is 30,720. This number right here, 28,160, that is the reported distance. So from switch 1's perspective, when he used his local bandwidth, delay, reliability, and load on Fast Ethernet 0/1, he came up with his own local distance of 28,160. And so that's what his distance is. And we can actually zoom in on that. We can do show IP EIGRP topology and then actually type in the network. Say, show me all the details of that specific prefix. And we can see right here, one successor, and then it tells us. So this is what switch 1 told us about. So switch 1 said my minimum bandwidth is 100,000 kilobits per second. My total delay is 200, actually the total delay is 200 microseconds. That's from router 2 to switch 1, and then switch 1's actual delay on his interface. And reliability and load, which is not factored as part of the formula because its K values are zeroed out. And then let's just finish this off here. I'm not going to go all the way. Let's just go now to switch 2 and configure EIGRP on switch number 2. So for that, I'm going to want to make sure I have a network statement activating EIGRP on this. And for that, I'll use a wildcard mask. I'll do network 2220 and then a wildcard mask to keep it that way. Router EIGRP 1223. No auto summary. Network 2220. Now watch what happens if I don't include a wildcard mask. So I just typed it in like that. My neighbor relationship just came up. But when I take a look at EIGRP, even though I typed in network 2220, you can see here that it just shrunk it down to network 2000. So router EIGRP 1223. Let's get rid of that, and I will lose my neighbor relationship. Okay, there it goes down. And now I'll type it back in, but this time I'll include a wildcard mask to preserve that subnet just as it is. Show IP EIGRP neighbor, and we can see that he has now formed neighbor relationship with the other device. And show IP route. We can now see that switch 2 has learned via EIGRP about the 121 network and the 111 network. Right here. Here's the 111 network, and here's the 121 network. And those also show up in our EIGRP topology table. And there they are. And notice that even the directly connected routes are in here. If you use the network statement, which you'll have to have at least one network statement to get EIGRP to do anything. Whatever directly connected network that router finds will also be installed into its own local topology table. Notice it says via connected. That's because I use the network statement. You can also verify EIGRP functionality by typing show IP protocols. Good command to see what routing protocols are running on your router and a variety of information about them. For example, routing protocol EIGRP. You can see here your metric weights when we talked about those in an earlier video, the K values. You can also see that EIGRP, like many other routing protocols, comes up with a router ID. Pretty much all these routing protocols that do come up with a router ID do it in the exact same way. First thing they do is they look to see if there's any loopback interfaces. And if there are, whatever the highest IP address is of the loopback, that's what's used as the router ID. So for example, in this topology right here, if I had enabled EIGRP on router 1, his router ID would have been 111.111.111.1 because he would have seen, oh, I've got a loopback, it's the only loopback, and so that's what I'm going to use as a name for myself. On switch number 2, we can see right here, 32322. So switch number 2 looked around and he said, well, I don't have any loopbacks, so of all the interfaces that I do have, my physical interfaces, which one has the highest IP address? He said, oh, right here, 32322. That's my highest IP address that I've got. So even though I did not include that in a network statement, he still picked that up and used that as his name, as his router ID. And we can see here our EIGRP administrative distance values. Right now, variance is not being used. The default variance is 1, which basically means we're not using variance. And we can see what networks on this local device have been activated for EIGRP. And we can see what neighbors we have. So we already talked a little bit about variance. I did the whiteboard on that. Some additional ways that you can tweak EIGRP. Let's say that you want to manipulate the routes and force the router to choose one path over another. Well, we know that when EIGRP comes up with its distance, it factors bandwidth and delay into its formula. So knowing that, we can go on to our various interfaces and manipulate the bandwidth and delay values to make an interface look better or worse than it really is, to manipulate how EIGRP sees that interface. And we've looked at all of these show commands here to verify the neighbor table, topology table, and the routing table. And some debugs that you can run to troubleshoot EIGRP. As an example, right here, I'll type debug EIGRP packet hello. And we should see every few seconds our hello packet. There we go. Sending hello, received hello. So now we can verify that hellos actually are coming in and going out. Turn off the debug with undebug all. Another thing I could do is I could type debug EIGRP packet update. Show me the update packets that you get. And so here's what I'm going to do. I'm going to go over to switch 1, and I'm going to shut down fast Ethernet 0/1. And so we should see that switch 2 learns of an incoming EIGRP update saying, hey, 1111 is gone. It's no longer reachable. So let me go ahead and go into switch 1. I think that was fast Ethernet 0/1. Let's shut it down. And we should see an update packet come in here shortly on switch 2, telling it that that network is no longer reachable. Show IP route EIGRP. Okay, well, an update should have come in because now we see that the 111 network is gone, but my debug did not capture it. Here's one additional thing you can do. Sometimes, like in this circumstance, you say, hey, I've got a debug on and I didn't see what I expected to see. What's going on? Well, EIGRP is kind of neat because in the background it's actually keeping a log of everything that it's doing. And you can view that log without turning on any debugs. Just show IP EIGRP event. And this is called the EIGRP event log. And here we can see, even though my debug didn't see it, we can see if I scroll down. So the way this works is this top message is the most recent message and then just gets older and older and older. So what I'm doing is I'm looking for the first mention of 1110. All right, here's 1110, metric set. And when EIGRP poisons a route, and in case you haven't heard that term before, route poisoning means I'm a router and I'm sending you an update saying this route is bad, can't get there through me. So I'm poisoning it, I'm making it unpalatable for you. The way EIGRP does that is when I send you an update, and for a particular prefix, I set the delay value to its maximum number. So whatever that number is, I just set to all ones, 1111111. That is called poisoning a route. And the result of that is you'll see this big, massive distance value right here. Whatever that is, 42,949,000,000 or something like that. You don't have to memorize that number, but you'll see this number often enough to recognize, oh, that is a poisoned update right there. So here he just received the poisoned update, and it was 2222 who was telling him that it was poisoned. And he's looking around saying, find feasible successor. Do I have any backup routes for this? And he's looking around and says, nope, I still can't get there. It's still poisoned. And if we scroll up a little bit, poison squashed, and then routing database delete. So he says, I'm going into the routing database, which is another way of saying the routing table, and I'm deleting 1110/24. So I'm not sure why our debug didn't capture that, but we can see clearly here from our EIGRP event log that he actually did receive the information about that network going down.